So finally we are going to assemble the global stiffness matrix. Already previous two videos we can see about the how to apply the nodal conditions and constraints, then how to find the element stiffness matrix. Now we are going to assemble the stiffness matrix. So node 1 will be sharing for two elements, and node 2 will be sharing for two elements, and node 3 will be sharing for two elements. So the value of 1 comma 1 1 comma 2 2 comma 1 2 comma 2 for node 1, and node 2 3 comma 3 3 comma 4 4 comma 3 4 comma 4, and then node 3 5 comma 5 5 comma 6 6 comma 5 6 comma 6. It will be sharing for two elements, so they're having a two values. So for 1 comma 1 28.284 into 10 to the power 3, and then 28.28 into 10 to the power 3. Node to 28.28 into 10 to the power 3 minus 28 into 28 into 10 to the power 3, and then 3 1 comma 3 minus 28 into 28.28 into 10 to the power 3. 4 comma 1, so 1 comma 4 minus 28.28 into 10 to the power 3. 1 comma 5 minus 28 into 0.28 into 10 to the power 3. 1 comma 6 28.28 into 10 to the power 3. 2 comma 1, they're having two values, 28.284 into 10 to the power 3 minus 28.28 into 10 to the power 3. 2 comma 2, they're having a two values, one will be in 28.28 into 10 to the power 3, and then 28.28 into 10 to the power 3. Node 3 minus 28.28 into 10 to the power 3, and then 2 comma 4 minus 28.28 into 10 to the power 3. 2 comma 5 28.28 into 10 to the power 3. 2 comma 6 minus 28.28 into 10 to the power 3. 3 comma 1 minus 28.28 into 10 to the power 3. 3 comma 2 minus 28.28 into 10 to the power 3. 3 comma 3, they are having a two values, 28.28 into 10 to the power 3 plus 40 into 10 to the power 3. And then 3 comma 4, they are having a two values, 28.28 into 10 to the power 3 plus 0. 3 comma 5 minus 40 into 10 to the power 3. 3 comma 6 0. 4 comma 1 minus 28.28 into 10 to the power 3. 4 comma 2 minus 28.28 into 10 to the power 3. 4 comma 3, they are having a two values, 28.28 into 10 to the power 3 0. 4 comma 4 28.28 into 10 to the power 3 plus 0. 4 comma 5 0. 4 comma 6 0. 5 comma 1 minus 28.28 into 10 to the power 3. 5 comma 2 28.28 into 10 to the power 3. 5 comma 3 minus 40 into 10 to the power 3. 5 comma 4 0. 5 comma 5 28.28 into 10 to the power 3 plus 40 into 10 to the power 3. They're having a two values. 5 comma 6 28.2 into 10 to the power 3 plus 0. So the minus 28.28. And then 6 comma 1 28.28 into 10 to the power 3. 6 comma 2 minus 28.28 into 10 to the power 3. 6 comma 3 0. 6 comma 4 0. 6 comma 5, they're having at minus 28.28 into 10 to the power 3 plus 0. 6 comma 6 28.28 to 10 to the power 3 plus 0. So this is the global stiffness matrix. After that, we are applying a boundary conditions. So node 1 will be fixed, so the corresponding displacements will be 0. So u2 v2 will be 0. Node 3 will be roller supports, so u v3 will be 0. And then the force acting at an node 1 at a vertical force, so f2 will be in minus 50 into 10 to the power 3. So applying this boundary conditions based on the displacement 0, so third row, third column, fourth row, fourth column, sixth row, sixth column will be negligible. So final values we will get as an 56.569 into 10 to the power 3 0 minus 28.284 into 10 to the power 3 0 56.569 into 10 to the power 3 28.28 into 10 to the power 3. So minus 28.284 into 10 to the power 3 28.284 into 10 to the power 3 68.28 into 10 to the power 3. A displacement of q1 q2 q5. The force of 0 minus 15 into 10 to the power 3 0. So based on these three equations, we will get the nodal displacements. So for node 1, 0.3125 mm for the horizontal displacement, and the node 1 vertical deformation minus 1.196 into 196 mm, and then node 3 horizontal deformation will be a 0.625 mm. So thank you. We'll see you in next video.